Next up is solving rational equations. So for example 1, we're going to solve each of the following rational equations. Starting with x plus 3 divided by x minus 4 equals x minus 1 divided by x plus 2. When solving rational equations, it's always a good idea to identify your domain. So for this example, we can't have an x value equal to negative 2 or an x value equal to positive 4. So of course one way to solve is to look for your solution graphically. And you can see we have a point of intersection right here. So what is that x value? We're not going to have point of intersections out here because they're not going to cross the horizontal asymptote, and similarly out in this direction. So now how do we solve this rational equation? So one way to solve rational equations is to cross multiply. So that means multiply both sides by x plus 2. So I'll get x plus 2 times x plus 3. And then multiply both sides by x minus 4, which will give me x minus 1 times x minus 4. Now it's like solving polynomial equations. We need to expand and simplify, and then move all the terms to one side of the equation. Finally, the last step is to solve for x. So since we have a linear equation, we just move the constant to the right side and divide by the coefficient in front of x. So the solution to this rational equation is x equals 1/5. If we want to verify our work, we can take that x equals 1/5 and sub it back in to our original equation. And we'll get that the left side is equal to the right side. We also see now that the two graphs intersect at x equals 1/5. So this one I'd approach a little bit differently. Before you cross multiply, you need to simplify the left-hand side to get a single term. So that means finding a common denominator and then simplifying the expression. So again, first off, remember we're going to state our domain. So we know that x can be any real number. However, x cannot equal 0 and cannot equal 13. All right, so let's rewrite this equation. So we have 1 over x plus 1 over x minus 13 is equal to 1 over 42. The common denominator for the terms on the left side is going to be x times x minus 13. So this rational term is missing an x minus 13. And this rational term is missing an x, or a factor of x. So what I have now is x minus 13 plus x over x times x minus 13, and that equals 1 over 42. So in the numerator, let's collect like terms. So we get 2x minus 13 over x squared minus 13x is equal to 1 over 42. Now we can cross multiply. And if we do that, we get 84 x minus 546 is equal to x squared minus 13x. If we move all the terms to one side, we get 0 is equal to x squared minus 97x minus 546. So let's check our discriminant. And 7,225 is a square number, so this quadratic has two real solutions, and this quadratic is factorable. However, this might be a tough quadratic to factor. So we can use the quadratic formula. We've already determined the discriminant to be 7,225. So we have two solutions to this equation. We have both x equals 6 and x equals 91. Again, we can check our work by subbing these two x values back into our original equation. And the left side should equal 1 over 42 if you sub in those x values. Notice that this one was harder to find the solutions graphically. Here's 6. But again, to find the second solution at 91, we'd have to extend this graph until we hit an x value of 91, which would be hard to find as these two curves are approaching each other ever so slightly. Alright, so let's look at a word problem. So the concentration of salt in a tank is given by the following formula. C of t is equal to 10t over 25 plus t, where C is measured in grams per liter. When does the salt concentration in the tank reach 3.75 grams per liter? As practice, let's see if we can graph this function. Again, the key features of a rational function are the vertical and horizontal asymptote. We know we have a vertical asymptote at t equals negative 25. And we have a horizontal asymptote at c equals 10. We also have a y-intercept. If we let t equal 0, we get 10 over 25. So let's just say that's here. So really, since we're looking at concentration over time, then all we're looking for is this part of the function. I don't need to worry about what's going on the left side of 0. Again, if you want to verify that this function is approaching 10 from below, sub in a very large number for the concentration. You'll see you'll get a number just below 10 as you sub in larger and larger values for time. So when does the salt concentration reach 3.75 grams? So we're going to let C of t equal 3.75. So next, let's sub that into our equation. We can cross multiply, remembering that we can't have a t value of negative 25. Next is to expand and solve for t. So I'll let you try that part, and you should end up with t equal to 15. So now we can state that the salt concentration in the tank will reach 3.75 grams per liter at 15 seconds. I'm sorry, I should have said 15 minutes. Okay, part B. Part B says, what will happen to the salt concentration over time? Well, the best thing to do is take a look at the graph. And you can see, over time, the salt concentration will just get closer and closer to 10. How can you show this? You can sub in a large value for time, and then an even larger value, and you'll see it'll get closer and closer to 10. Again, here are a few questions that you can try. And good luck.